Hey there, math enthusiasts. So we just did, multiplying rational expressions. Now we're getting into adding and subtracting rational expressions. So that's your daily question. How do I add and subtract these fractions? As it turns out, it's a little bit more complicated. There are a little more steps involved because of the way that adding fractions works. So let's remind ourselves how adding fractions works. Unlike multiplication, I cannot just add the tops and the bottoms. That's not how it works. What I need to do is I need to make sure I find the least common denominator, or LCD for short. So I need common denominators to add fractions. In this case, I have a 2, I have a 5. I think the LCD is going to definitely be 10. So I need to have this fraction have a 10 on the bottom. I need to have this fraction have a 10 on the bottom. So for this fraction, what I do to the top, I do to the bottom. So let's multiply by 5. Now the bottom looks like 10, but since I multiply by 5 on the bottom, in order to keep the fraction like the same, balanced, I need to multiply by 5 on the top, so 5 times 1. Over here, to get 10, I need to multiply by 2. And when I add them together, I get 11 over 10. Remember, I just then add the tops. The bottom stays the least common denominator. So review of adding fractions. Yeah, that terrifies people. I don't know why. It's really, really easy. You just get a common denominator. Like, it's easy. So here's the deal. We need to use these, same rules when we're adding fractions that have variables involved. So let's look at the first example here. Notice that, yeah, I have fractions, but unlike the fraction on the previous slide, I have variables involved. Same rules apply, though. I need to have a least common denominator. So let's look at these fractions. Look, they both have the denominator of 4x. So when I add them together, I'll have 4x on the bottom. And then I simply add the numerators. 7 plus 3, 10. And I'm done, but I should look to see if I can reduce the fraction at all. Here, since I have multiplication on the bottom, I definitely can reduce. I think 10 over 4 reduces to 5 over 2. So there we go. Here too, my denominator is super duper weird. I'm recording this at school, hear the bell? The denominator is super, super weird, but it is in common, right? So that means when I subtract these two fractions, I will have x plus 6 as my denominator. It looks weird, but it makes sense. I have a common denominator. Then just subtract the numerators. They're not even like terms, so there's not much to do. 2x minus 5. Now remember, you're not allowed to cancel this x. That would be canceling within addition. Very bad. I should look to see if there's a GCF or something on top. Maybe there's some cancellation that can occur after I factor. But here, there's definitely no way to factor, and so this is going to be my final answer. Not too bad, right? Unfortunately, as with all math, this is just the introduction. It gets harder. So let's look at one of the more legitimate examples. Here, I have a monstrous fraction plus another monstrous fraction. How the heck am I going to find the LCD here? They're not even close. So here's the strategy. A really good first step in order to find the LCD is I should definitely start by factoring the denominators. Starting by factoring the denominators helps me to see what I should multiply by to get that LCD. So let's just factor the denominators. First fraction, there's nothing in the denominator to factor, so let's just leave it. Second fraction, in the denominator I can definitely pull out a 3x, and that leaves me, whoa, what am I doing? I'm pulling out a 3x, and this leaves me with x plus 1. Now, if you notice, since I have multiplication now, I could cancel these x's, but let's just not, because as we're going to see, I need to not do that so that I can get a least common denominator. You could do it, but I'm going to end up multiplying by some x's anyway, so that I can get the denominators to look the same. So let's take stock of what I have in each denominator. This denominator has a 9 and 2 x's, right? And x squared. Let me just write that out. 9x. This denominator has a 3 and an x, and it has this x plus 1 term. Now, in order to get the least common denominator, I really need to make sure that this fraction this denominator and this denominator have everything in common. And I can only really go up. Like, remember on my previous example, when I had the 2 and the 5, I multiplied up to get the 10. I multiplied up to get the 10. We need to do the same thing here. So for example, here's what I mean by this. This fraction has a 9 in the denominator, but this guy only has a 3. So what do I need to multiply this fraction by? Well, it definitely needs another 3. Now if I do 3 times 3, it's going to be 9. Likewise, this fraction has 2 x's, but this fraction only has 1 x. That means I need to give it another x. So let's multiply by another x. Notice this x times this x will now match, and they'll both have an x squared. So, okay, what else? We kind of took care of this stuff, and we took care of the 3 and the x. Oh, this fraction has an x plus 1. This fraction does not have an x plus 1. So I need to multiply my first fraction by x plus 1 in the denominator. Now, remember, whatever I do to the bottom, I need to do to the top. And I think I have decided what needs to happen for the bottoms to look the same. I need to do the same thing to the top, though, because remember, multiplying by, for example, x plus 1 over x plus 1 is the same as multiplying by 1. So, on the top, let's actually distribute. This will give me 7x plus 7 over 9x squared times x plus 1. I don't need to distribute down there because remember, now that I have my LCD, that's just going to be the denominator for the rest of the problem. So I don't need to distribute in because I would end up factoring it out anyway. With the other fraction in the denominator, I have 3x times 3x. This is 9x squared. And then I still have the x plus 1. So notice, both denominators now look the same because I gave this denominator everything that the other denominator had, and I did the same with the other denominator. On top, I just have x times 3x, so 3x squared. I know this is a little bit tricky, but I'll do one more example, and then obviously we'll do plenty in class. Okay, so let's add these up. This is the easy step. I have common denominators now, and so the bottom is just going to be that common denominator. On the top, I don't even have any like terms. 3x squared plus 7x plus 7, like that's it. There's nothing to combine. There are no like terms. I should look to see if I can factor it all, but I don't think this factors. Like it definitely doesn't. So I'm not going to be able to factor, which means I'm not going to be able to cancel. This is a crazy answer, but it is the answer. Let's look at one more really hard example like this. So here's another one. Whoa, these fractions are absolutely insane. Again though, let's focus on first finding that LCD, and we know that we need to factor the denominators to help me to find that. So first fraction, I have x plus 2. Factoring out the denominator, I think I can pull out a GCF of 2. That leaves me with x minus 1. Then I'm subtracting negative 2x minus 1. Nothing's changed up there. On the bottom, okay, this will factor into x minus 1 times x minus 3. So keep in mind what I need to do here. Everything that this denominator has, but this denominator doesn't, I need to give it. Everything that this denominator has and this denominator doesn't, I need to give it. So let's look. They both already have an x minus 1. Yay, so that's good. It's taken care of. They both have an x minus 1. This denominator has a 2. This denominator needs a 2, so I need to multiply at least by 2 over 2. Okay, that takes care of the 2. The only other kind of part is x minus 3. This denominator has an x minus 3. This denominator needs an x minus 3. So I'm going to multiply by x minus 3 over x minus 3. Now remember, when we do this, I'm going to leave the denominators nice and factored out. So on the bottom here, I have 2, x minus 1, x minus 3, nice. On the bottom here, I have 2, x minus 1, x minus 3. So my denominators really do match. On the top, though, I have some trickiness. Notice, there's actually, if I put the parentheses here, there's actually FOIL going on between this guy and this guy. So because of the FOIL, yeah, I got to do that. So let's FOIL it out. I can do it mentally. X squared. I have plus 2x and then minus 3x, so minus x. And then I have minus 6. Okay, so that takes care of the numerator there. In the second fraction, I just have distribution, so this will be negative 4x minus 2. Except, here's a strategy. Now that I know I'm going to be subtracting, I know my denominator is going to stay the same, but notice that I really am subtracting this time. I'm no longer adding. And remember that when we subtract, it can get a little bit tricky. Sometimes it's easier to think of distributing this subtracting in. So let's do this. Let's distribute in the subtracting. That'll change it into a plus. And each sign is going to flip here. So plus, plus. It's just like I'm multiplying negative 1. Basically what I did is I did negative 1 times negative 4x minus 2. I distributed in, now it's just 4x plus 2. And that'll make my life a little bit easier when I look to combine the like terms. So speaking of combining like terms, x squared, I have a negative x and a plus 4x. And remember, I'm adding them, so I can kind of just do this mindlessly. I'll get plus 3x. Then I have a minus 6 plus 2, which is minus 4. Okay, great. Now here's the deal. Like I said, this could be the final answer, but I need to look to see if I can factor it. And as it turns out, it looks like I really can factor the top. So this is a really crazy problem. Let's go ahead and factor the top. I have x plus 4, x minus 1, and look what showed up. There's an x minus 1 on the top and an x minus 1 on the bottom. So kill, kill. That leaves me with x plus 4 over 2 times x minus 3. Whew. Yeah, that problem was insane. This is literally the hardest it gets. I cannot imagine a harder problem. Like, this is as hard as it gets. If you can do this, if you understood all the steps we went through, you are more than good to go. So let's just talk about those steps real quick. First of all, I factored the denominator, okay? I factored the denominator of each fraction, and the reason I did that is because it helped me to see what the least common denominator was. To find the least common denominator, I decided that this first fraction needed an x minus 3, and this second fraction needed a 2. Now both of the denominators are equal. There were some other crazy things, like on the top I had FOIL, here distribution, here I distributed this negative in, then I combined like terms. But even after combining the like terms, I had to go and factor the top because, as we saw, something canceled. So this is the kind of problem that makes a math guy like me smile. They are so crazy, they involve so many different kinds of math, satisfying to complete. Summary, super important to factor the denominators to see what kind of least common denominator you can find. So definitely, if nothing else, just make sure to start by factoring the denominators. Oh, I just ate, so I'm like hiccuping. Okay, that's it. Way to make it through this very long video. Bye.